Flow is defined as the quantity of fluid that passes a point per unit time. There are two types of flow: laminar flow and turbulent flow. Laminar flow. In laminar flow, liquid flows over a horizontal surface with a steady flow. Although all the molecules are moving in a straight line, but the velocities of all the layers are different from each other. If the mean velocity of the flow is v, then the molecules at the center of the tube are moving at approximately 2v, while the molecules at the side of the tube are almost stationary. Thus, a flow in which the liquid moves in layers is called laminar flow, as shown in the figure. Here, two boats are dropped in the river simultaneously at different places. The boat dropped in the middle of the river flows much faster than the boat dropped at the edge of the river. This happens because the velocity of river water in the middle is more than the velocity of river water at the edge. Turbulent flow. In turbulent flow, the path and the velocities of the particles of the liquid change continuously and haphazardly with time. When an object is placed in the path of moving fluid, it causes turbulence as shown in the figure. The speed of river water and hence the movement of the boats change. When it strikes a rock or stone on its path, there is said to be turbulence in the flow. To understand the fluid's flow, let us focus over a particular fluid particle. The path followed by the particle shows the streamline. There is crowding of streamlines in the narrower portion of the pipe. Here, the velocity of the particles is faster in comparison to the velocity of particles in the wider portion of the pipe. Hence, the streamline for liquid flowing through a pipe of varying cross-section look like that. According to the principle of continuity, for laminar flow of non-viscous and incompressible liquid, the mass of liquid flowing through any cross-section is a constant. Since the liquid is incompressible, the density remains same and hence the volume of liquid flowing through any cross-section is a constant. It is very clear from the area velocity graph that velocity is inversely proportional to the area of cross-section. While watering the plants, one can increase the speed of water flowing out of the pipe and hence can sprinkle water over larger area by reducing the area of cross-section by partially closing the pipe with the thumb.